All right, you guys, let's come back to 18C. I think we're at, and I think this is 1 over x, I think this is 1 over 5, and I think this is subtraction. So it looks messy, but you guys, it actually isn't. If we just rewrite this, there's nothing I can simplify in the top right now, but I have 1 over x minus 1 over 5. But the denominator, you guys, it's that rule. 1 over x is a perfect square because 1 over x times 1 over x is 1 over x squared. I meant 1 over x squared is a perfect square, right? So the square root of 1 over x squared is 1 over x. And the square root of 1 over 25, you have probably already made the leap to this, is 1 over 5. 1 over 5 times 1 over 5 is 1 over 25. Okay, so what that means is the rule says I take the square root of the first term, okay, and I'm going to put parentheses here. You'll see just a second. 1 over x, 1 over x, and then the square root of the second term, 1 over 5, 1 over 5. And because this is subtraction, 1 is going to be plus and 1 is going to be minus. So check it out. Check it out. I use that with my puppy. This is the same exact thing as this. So what I really have is 1 over 1 over x plus 1 over 5. All right, and D, you guys, it doesn't look like it now, but I promise you it is. 9 minus x to the negative 2, those 9 and x to the negative 2 power are both perfect squares, so we can just use that rule I've been talking about. The square root of 9 is 3 times 3, right? And the square root of x to the negative 2 is x to the negative 1 times x to the negative 1, or just x to the negative 1. But I just wanted to show you, don't get confused because they're negative. This negative exponent times this negative exponent does not make a positive exponent because we're not multiplying the exponents, right? We're adding the exponents, and negative 1 plus negative 1 is negative 2. So the numerator is going to be 3 plus x to the negative 1 times 3 minus x to the negative 1. And we cannot simplify the denominator anymore, but look, sorry, it's not a straight line. But look, you guys, we have 3 plus x to the negative 1. So obviously those cancel. And our most reduced answer here is 3 minus x to the negative 1. Sorry, minus x to the negative 1. I guess you could write that as 3 minus 1 over x. I don't know if that makes it any better or not, but remember, I can make that exponent positive by putting it on the denominator. Okay, let's see, what's next? Factor completely. So look, you guys, before I start freaking out about my exponents here, I'm going to start by saying both x to the 6th power and x to the 4th power have at least 4 x's. So this first one I'm going to do a long way to show you what's going on, but then I won't moving forward, okay? But x to the 6th power is really x times x times x times x times x times x, okay? And 16x to the 4th power is really 16 times 1, 2, 3, 4. So look, let's figure out what they have in common here. And they both have 4 x's, right? 4 x's, 4 x's. Sorry, you guys. So I can factor that out, right? If I factor out 4 x's, or x to the 4th power, what I have left over, here I have x squared left over, right? And here I just have 16. So now, look, it's that same rule that keeps coming back to haunt us, you guys. X squared is x times x. And 16 is 4 times 4. And you guys let me put a plus here, but I shouldn't have. Obviously, that's subtraction so that our rule works, right? How many of you were yelling at the computer while I made that mistake? I hope everyone noticed that. Okay, but now I have, let's see if you can figure this out. Pause right now and see if you get the right answer. x to the 4th times x minus 4 times x plus 4. And it doesn't matter if I do the plus or the minus first, okay? All right, next one. The next one looks like a little bit tougher because I cannot take an x out of every term because this 50 over here doesn't have an x. What I'm going to need to do is, I'm going to erase this, factor by grouping. And I know we did this a little bit last year, but I know it's one of those things that's going to be hard to remember. So factor by grouping, we're going to group them up. So I'm going to put kind of like this line in between here. Again, good for your notes, right? Factor by grouping. And we're going to factor out the greatest common factor here with the first two terms. So 4x cubed is really 4 times x times x times x. And 8x squared is really, and I know you want to say 8 times x, which is true, but I kind of want to get a 4 here. Maybe I can factor out some more stuff. So 8 is really 4 times 2, and then x squared is x and x. And the reason that's important is because I can factor out not only x squared, but I can also factor out this 4. So I can factor out 4x squared. So from the first two, 4x cubed minus 8x squared, I'm going to take 4x squared out. I'm going to factor that out. And what I have left on the numerator is just 1x, or on the numerator, and these 4x cubed, what I have left is just x, and what I have left here is just 2. So what does that look like? X minus, I have to use that minus because this is a minus here, 2. Okay, now let's do the same thing with negative 25 and positive 50. Well, obviously this is easy in our head. 25 and 50 both have 25 in common, right? But check this out. Up at the top here, I'm going to do this. If I take 25 out, if I factor that out, what I have left over is negative x plus 2, right? 25 times negative x is negative 25x, which is the first term. 25 times 2 is positive 50, which is the second term, which is all perfectly good, except, you guys, I know in order to make factor by grouping work, I want to get x minus 2. That's what's going to make the whole thing work. So check it. If I, instead of taking 25 out, if I took negative 25 out, I would just multiply it by regular x and negative 2, because negative 25 times negative 2 would give me 50. I know it seems simple once somebody does it, but you just need to recognize that as you're going through it. So now I have minus 25 times x minus 2. So now, instead of factoring out something from each side, I'm going to factor out from this whole huge polynomial x minus 2, because we have x minus 2 here in this term and we have x minus 2 here in this term. So now if I factor out that x minus 2, what do I have left over? I have 4x squared minus 25. So now there's one more thing, you guys, but wait, there's more. Did anybody see it? Yep. 4x squared is a perfect square and 25 is a perfect square, and we're subtracting them. So we leave the x minus 2 and we change 4x squared minus 25 to be the square root of 4x squared, which is 2x, and the square root of 25, which is 5, and 1 plus and 1 minus. There you go, you guys. And the last one, 8x cubed plus 27. There is a rule for this that I am not going to expect you to know right now, and I can go over it in class. If you are taking Miss Stewart, you're going to have to ask you what she expects you to know. I will say one thing, if you want to look it up and be super dope and like figure this out before I tell you in class, 8x cubed is a perfect cube because 2x times 2x times 2x is 8x cubed. And 27 is a perfect cube because 3 times 3 times 3 is 27, okay? So we have two perfect cubes being added together, and there is a rule for that, okay? So see if you can look it up and figure it out while we move on to x to the fourth minus 1. Okay, x to the fourth is a perfect square of x squared times x squared. 1 is a perfect square of 1 times 1, so we're just going to use that with third being subtracted. So x squared minus 1 times x squared plus 1. See how fast those rules make it? True or false? The number 3 to the negative second power is negative. Well, let me just show you what it is, and you tell me and justify the answer. 3 to the negative second power is really 1 over 3 squared, which is really 1 over 9. Is that positive or is that negative? 21, true or false? If 4 cubed is equal to 2a, then a is equal to 6. Well, let's see. To make this easier to understand, let's turn 4 into a 2. 2 squared is 4, right? So instead of having 4 cubed, we actually have 2 squared, which is 4, cubed, right? Which is equal to 2 over a. And if our base is both 2, our exponents have to be the same. So what happens when we take this power to a power? If you remember from last year, we take this as an a, not a 9. It looks kind of like a 9. This side would really be 2 to the 6th power, which means a must be equal to 6. Right on, right on. I'm going to stop here for this video. Start with question number 22 next time.